Hello everyone, I'm Janvi. As you see on the screen, our today's topic is Lagrange's interpolation. Topics to be seen in this session. We would study what is Lagrange's interpolation and its advantages and disadvantages and real-time applications, and we would study more on signal processing, which is one of its applications. Lagrange's interpolation. So what is Lagrange's interpolation? Lagrange's interpolation is a mathematical method used to appropriate a function or a set of data points with a polynomial. This interpolation technique was developed by the French mathematician Joseph-Louis Lagrange in the late 18th century. It is widely used in various fields including numerical analysis, engineering, and computer graphics. The goal of Lagrange's interpolation is to find polynomial that passes through a given set of data points. Suppose we have the distinct set of data points that is from x1 to y1, x2 to y2 till xn to yn, and we want to find the polynomial p of x, but in terms of formula it is given f of x where both are similar that passes through these points, and the formula is given. Advantages and disadvantages of Lagrange's interpolation. Advantages of the formula. Lagrange's formula fits into a range of mathematical structures and provides continuous values even when computed polynomial functions are at discontinuous at some endpoints. Disadvantages of the formula. Although the formula is intuitive, it can be computationally expensive due to having to compute a new polynomial function or each new data set or subset of data. So now let's see some real-time applications. Numerical analysis. Lagrange's interpolation is widely used in numerical analysis and numerical methods. It allows the estimation of values between data points, facilitating the construction of continuous functions that can be easily evaluated. Function approximation. Given a set of discrete data points, Lagrange's interpolation can be employed to construct a polynomial that closely approximates the original function. This is particularly useful when the original function is complex or difficult to compute directly. Curve fitting. Lagrange's interpolation can be utilized to fit curves to data points in data analysis and regression tasks. By finding the interpolation polynomial, one can represent data with smooth curves, making it easier to visualize trends and make predictions. Computer graphics. In computer graphics, Lagrange's interpolation is employed to generate smooth curves and surfaces. It is commonly used in graphics software for tasks like rendering, image processing, and animation. Signal processing. In signal processing, Lagrange's interpolation is used for resampling and reconstruction of signals. It helps to convert discrete signals into continuous signals or to change the sampling rate of signals while preserving important features. Control systems. In control engineering, Lagrange interpolation is utilized to generate continuous control signals from discrete control points, enabling smooth control of system. Scientific data analysis. Lagrange interpolation is employed in scientific data analysis to fill in missing data points or to obtain values at a specific points in experiments or simulations. Polynomial evaluation. Lagrange's interpolation provides a method for efficiently evaluating polynomials at various points, which is useful in numerical integration, solving differential equations, and root finding. Error detection and correction. In some error correcting codes and checksum algorithms, Lagrange interpolation is used to reconstruct missing or corrupted data to recover the original information. So let's study what is signal processing in depth. Signal processing is one of the application of Lagrange's interpolation. We know that signal processing is very much used in domains like communication control, image and video processing, radar, sonar, geo. So these are the steps where Lagrange's interpolation is being performed. Signal reconstruction. In some cases, a continuous signal may be sampled at regular intervals to convert it into a discrete signal for processing or transmission. After processing it, is often necessary to reconstruct the continuous signal for further analysis or display. Lagrange's interpolation can be used to recover the continuous signal from its discrete samples. In simple words, it is used for reconstructing continuous signals from discrete samples. Data resampling. In signal processing, it is common to change the sampling rate of signal. This can be achieved using interpolation technique. By applying Lagrange's interpolation, one can resample the signal at different sampling rate while preserving the signal's characteristics as much as possible. So here Lagrange's interpolation is used for changing the sampling rate of signal data, that is resampling the signals. Signal interpolation. When there are missing or corrupted samples in the discrete signal, Lagrange's interpolation can be used to fill the gaps and reconstruct the missing values based on available data points. In simple words, filling missing or corrupted samples in a discrete signal, that is in the required signal. Signal visualization, interpolation using Lagrange's method. Signal visualization, interpolation using Lagrange's method can be employed to visualize signals more smoothly. It is useful when plotting signals or displaying them on a continuous domain. That is smoothing signal visualization, which is used for plotting and displaying it. However, it is essential to be cautious when using Lagrange's interpolation in signal processing, especially for high frequency signals or signals with complex dynamics. Thank you. I hope that this session was informative.